Hi there, everyone. My name is Juliet Gonzalez, and today I'm going to be talking about understanding the domain of a function. And throughout this presentation, I'm going to be going into the breakdown of the domain and vertical asymptotes, and we're going to learn further into what that is and why it is. So for this main project, we were here to see this function, and the function that was given is f of x equals 1 over x minus 3. For this specific portion, we were supposed to determine the domain of the function and express that in interval notation. So how I was able to find the domain of this function was by inputting different numbers. And so with that, I was able to conclude that the domain can be all real numbers except for 3. And the reason that is because if we were to plug 3 in, and if we set it as x minus 3 equals 0, if we were to plug in 3 to where x is, it would be 3 minus 3 equals 0. Therefore, if x were to equal 3, the domain would have to include all real numbers except for the number 3. And the reason that is because if the expression itself were to equal 0, it would cause the denominator to equal 0, and nothing can be divided by 0. So the function itself would then become undefined. It would give an invalid input. And so when we express this in interval notation, it would be negative infinity to 3 union, which brings it all together, 3 to infinity. And I'm going to go further in depth, and you're able to see on the graph why that is set up that way. So the main question of why does the domain exclude certain values? Why is it excluding 3? So the domain excludes any value that makes the denominator equal to 0, because division of 0 is undefined in mathematics. For this specific function, f of x equals 1 over x minus 3, substituting x equals 3 would cause the denominator to become 0, meaning the function could not produce a valid output, and then would make this value completely undefined. With that, we want to make sure that the domain includes all real numbers except for 3, so that way we can keep this function properly defined. Let me see here. So that's why we are excluding x. That's why we're excluding x equals 3 from the domain. So what is a vertical asymptote and how does it apply? A vertical asymptote is a line on a graph where the function gets very, very close. It's where x almost meets it, but it never reaches or touches the line directly. Here we can see that in this function, x approaches 3, the denominator itself gets very, very close to 0, causing the value of the function to either grow extremely large in a positive direction or decrease in a very large negative direction. And so here in the background is the exact graphing of the asymptote x equals 3, which in this specific function, the vertical asymptote would be that excluded value, that excluded expression, which is x equals 3. So here we can kind of see on the graph in the background, that is the graphing of this vertical asymptote x equals 3. So here towards the top right, we can see how the line comes and it's going so close to that 3 on the x line, but it will never touch it directly. It'll just continue to ride and coast along that line, but it will never reach it. And so that's how it can grow in a very positive direction. And so when it's going in a very negative direction, we can see towards the bottom left how even though it's going negatively, and it looks like it may get very close to touching the line eventually. When you get to infinity, it looks like it may possibly touch. It never will. It will always ride that line specifically. And so that breaks down what the vertical asymptote is, and just how in this expression specifically, or in with this function specifically, x equaling 3 is where, because of the denominator and how that plays, it'll never go to fully touching that line, or it'll never meet it. It will always get very close and either be again negative infinity to 3, where it's almost barely touching, that's its limit, that's its do not cross line, or it'll be 3 to infinity. And so if someone were to, of course, if I were to be presenting this and someone were to ask me, why can't x equal 3 be the domain? If x equals 3 were to be plugged into the function, then the expression would be 0. And so if it equals 0, then that makes the function undefined and there would be, once again, no valid output. And so if the denominator equals 0, then it would be completely invalid because nothing can be divided from 0. So x equaling 3 could not be the domain and has to be one of the excluded values because it would make the function invalid, undefined, and wouldn't follow the rules within functions and be properly defined like it should be in mathematics. So to summarize everything I just told you, I know it was a lot, but the domain of the function presented, f of x equals 1 over x minus 3, the domain would therefore have to be all real numbers except for 3, which in interval notation is negative infinity to 3, union, bringing it all together, 3 to infinity. And then certain values do have to be excluded because they would make the denominator equal 0. They would make the function have an invalid output or make it completely undefined. That vertical asymptote is going to be what we consider our do not cross line. It's going to be the limit for our function if we were if we were to graph it. And so when this is listed, you can see how x gets very, very close to the value of 3, but to infinity, whether it's in a positive direction or negative direction, it'll never touch it. And so the domain could never, for this specific function, be x equals 3 because it would make the function itself completely undefined. And we like for all of our functions to remain properly defined. So I thank y'all for taking a listen, and this is how we break down the domain and vertical asymptote.